Hi everyone. Sorry I can't be there in person, but we'll do the next best thing with this. So largely, I'm just going to be providing an update for where I am in the Swayze area project, and kind of go over just the next few things that need to be done. So just the research and funding partners. So just a quick outline. So just going to go over the problem quickly, where I'm at. Just a very quick review on the volcanic evolution and architecture, and then mostly talking about what's going on with the metal endowment part of the project. So the research problem for the Swayze has always been, because it's the western extent of the well-endowed Abitibi greenstone belt and contains the same chronostratigraphic episodes or assemblages, why does it have less base metal endowment compared to the central Abitibi? So basically, once you cross over the Kanagamissi batholith to the east, that's the big question. And then, as we can see here, we have a large amount of VMS tonnage within the Deloro, the Gemmell, and the Blake River assemblages. So again, addressing why the Swayze VMS production has been zero to date. So where I'm currently at. So just to zoom into where the Swayze is, I'm sure we're all aware at this point, but it's the southwestern part of the Abitibi. This has always been the description or the slang. So the poor cousin was always the Swayze area, and the rich cousin was always to the northeast. Gold was zero, but of course with Cote gold producing and with the Gosselin deposit, that's changed quite a bit, but we still have zero VMS tonnage or nickel copper PG to date. So this is what it looked like prior to starting to map again in 2015 with the Ontario Geological Survey. That's just showing what it looked like and then where we're at now. So each one of these areas represents a map that has been released by the OGS and or in some fieldwork with Metal Earth. This past field season finished off this map in the southwestern area and then continued a bit westward. So we're basically working our way westward across the belt, and then we'll head back up again towards the north. So that's where we're currently at. And to date, we're actually over 2,000 geochemical analyses from the Swayze area. So quite a lot of information, which is fantastic. All right, so just this is just going to be a few slides. So finally, the first manuscript, the crustal architecture and revised geochronology of the Swayze area, southwestern Abitibi greenstone belt, has been submitted to CGES. So big thank you to everyone with the big monumental effort recently to get everything together to finally get this out. So that's fantastic. These are just a few figures from it showing which I'll be talking to you about in a little bit, the Jefferson and Vencan deposits and the Shunsby area, and then a couple others, Coach and Gosselin, of course, down there having a little bit of chalcopyrite, a little bit of copper associated with it. But the Jefferson, Vencan, and Shunsby area. And then also, just to highlight that we've released 24 new supercrustal ages. So these aren't largely having intrusions. So these are all volcanics and or sedimentary rocks that are being released through this publication. Okay, and so why is the Swayze area so important for the metal endowment of the Abitibi? So as we can see, these are just the base metal deposits, VMS and or nickel copper PGs across the Abitibi. And as we see, you have mineralization within each of the episodes across the Abitibi. So as we see, these are the number, this is just specifically VMS, but the number of deposits per episode, the most important are obviously, we have the Blake River, we have the Deloro, and of course, Gemmell as far as tonnage goes, represented by Kid Creek. And these are the main general areas. There's obviously lots of others, but these are kind of the main stereotypical VMS camp areas. So the significant thing is, I've just changed the coloring to largely match what was released with this most recent publication. We have all three of these assemblages. So it's a really important comparison because we have those same assemblages in the Swayze, we don't have the base metal mineralization like we do in the rest of the Abitibi. And this is just showing what the mineralization is like in comparison. So in the western Abitibi, so the Swayze area, most of the VMS is within iron formations between episodes. And then everywhere else in the Abitibi, we largely have it within these assemblages episodes. So a quick fundamental difference and just showing the representation of what they're sitting in. So this is just showing, again, where those are. So the main ones I'm going to be talking about are Shunsby, Jefferson, and Vencan, and they're all located within the Woman River Iron Formation, which I'll refer to as the WRIF, or the RIF, for the rest of the talk. So let's get into those. So I had a master's student, Blake Mowbray, who did an excellent job of field mapping in the Jefferson, Vencan, and Stackpool areas over 2017, 2018, but he unfortunately did not finish his master's. So basically I had to take all of his information and then figure out if there were any holes, et cetera, of what needed to be done. So just going to go over quickly what he did. This is just an idealized strat section representing Jefferson, Vencan, and Stackpool. So we have massive sulfide lenses, we have stalker mineralization underneath, and then we have sediments with what he had as basalts and or gabbroic sills coming through these sediments on top. And these are just a couple photos showing this is the footwall alteration, and then of course massive sulfide mineralization within the formation itself. So when you had trench maps, so this is representing the kind of upper section where we had sediments. He has basalts and gabbros and later porphyry intrusions coming through, and then his limit of alteration. This was just showing that it had a non-compliant resource of 30,000 tons at 7 zinc, 4.6 lead. This is just representing the upper section, and then the lower section, which had more sulfide facies mineralization, just highlighting that mineralization was actually cross-cutting the beds in lots of areas there. And this was his idealized cartoon for what was going on in all of those areas. So you had your chlorite and garnet alteration pipe, so your stockwork zone coming up, and you had a bit of a sericite alteration halo. And then he had garnet alteration within the sediments and not within the basalts on top. So basically this is where the state of things were. He had lots of information within the mineralized zones themselves, but within some of these more distal areas, what's going on in the bigger picture, that information wasn't largely collected. For example, I mean, in this situation right here, you have a basalt or mafic metavolcanic rock coming through, and there's no alteration in it. Yet if you're dilating sedimentary units that were presumably there before you had your basalts, you should have some alteration cross-cutting these as well. So I had to go in and look at some of these areas. So I'm just going to show what I've done over the past couple of years to make up for that. So this is just zooming into a map. This was kind of the most detailed recent geology map of the Jefferson and Vencan area, Jefferson being right here, Vencan being over here. And this was, oh, we'll just zoom into this. So this is, I'm just showing that it's just in this area here. So there are about 67 stations within this, just this area, largely centered on where, like I said, the main mineralization was. So lots of information and thin sections and everything else. So everything there was fantastic. But as you can see, kind of these basalts or sills or whatever they truly are coming across between iron formation horizons, kind of a more regional picture. We just didn't know that information hadn't been collected. So in 2024, 2025, I went back out, and so there's 141 stations represented in just this area alone. And every single one of these stations and or samples was not a mineralized zone. I did not take one mineralized sample. So these are either non-mineralized iron formation or mostly all the other rocks in the area, whether they're the volcanics, sediments, intrusions, etc., just to try and get a better idea of what was actually going on in the big picture. So this is just everything together. And then I've already started putting together not cartoons, but actual alteration maps. So these are representing where we saw garnets within those stations, whether they're in the footwall or sediments. None have been seen in volcanic sills in between their formations here. So that's one early interpretation that these are all mafic sediments and or dilational sills coming across and not actually true volcanics. So just a bit more regional context of what's going on here. So more fieldwork was required. And then also in Jefferson, there weren't any orthomosaics using the drones, so did that as well. And this is just a couple examples. So this is one of those dilational gabbros coming across. Not one of these gabbros have any volcanic textures that we can see like pillows, and there's iron formation on either side of it. So just trying to figure out what these things are doing. This is the Bencan showing, and this is all the sulfide facies, rhyolites underneath with garnets in them, and then more silicate facies stratigraphically on top. So I'll show with the Shunsby example of what's going on with these, but basically just producing as detailed geological maps on top of these orthomosaics as possible. So the Jefferson and Bencan area, basically the work that I've done and is ongoing is filling in the geochemical gaps. So that happened over the past couple of years. Obtain those orthomosaics, merged, and continue thin section analysis. So all of what Blake had done, and then adding all of kind of the more alteration story on top of that. Same thing with the geochemical fingerprinting, digitizing Blake's graphic logs that he did of the drill holes that he got from there, and then finally characterize the Jefferson and Bencan base metal prospects. So that's all looking to be done this year. And then we're just going to go within the same Wagner iron formation over to the Shunsby area. That's down here. So we've just moved over here, but it's representing the same time period. So we have iron formation that's been a lot more folded in this area, but we're going to look at a couple areas here quickly. And just pointing out, again, non-compliant, but there was a historical resource, 2.6 million tons at 1.8 zinc and almost 0.5 copper for this area. So this is the North prospects. So I showed this image 2 years ago. So main upper copper knob and the North main zone. And these are just some examples of all the orthomosaics. And before I did show kind of the detailed mapping that was going on using the imagery just to make very, very detailed geological maps to help show the context of what the mineralization and alteration is doing in the area. During or just after COVID, I was trying to also log some drill holes there. So in 2021 went out, this was the state of the drill core. There were 6 holes historically drilled just to sister old holes. As you can see, this is what it was like when I got there. So most of the holes were actually lost, unfortunately. But I was able to map 2 and then try and organize as best as possible for leaving. So we weren't sure if we were going to include these or not, but this past year, we submitted 80 samples from these 2 holes for geochemistry and polished thin section, most of which we've got the thin sections back and just waiting for the geochemistry just to help organize with what's going on at surface. And these are just where those 2 drill holes are. So the north zone is right here, and then the south zone is over here. And then just showing at surface, there's a lot of, I mean, it's an iron formation. There's a lot of mineralization, and it's all rusty now, so it's hard to see some of the relationships. So it was really important to use some of this drill core. As you can see, some mafic volcanic and or synvolcanic intrusions with some kind of varials in it. So going through this currently, have all the logs, but need to digitize them and then go through the thin sections for more detailed observations of what's going on. I mean, we have some infilling chert here, which is interesting, into some volcanics. This sample down here, we have chloritized volcanic fragments with very angular chert fragments. We have younging directions within core, which was spectacular. So able to figure out a bit more regional context, which we wouldn't have been able to otherwise. And then, of course, the timing of mineralization. This is just zooming into largely pyrite pyrrhotite mineralization, a little bit of chalcopyrite and sphalerite in places, and what it's doing. So that work is ongoing right now. So continue the thin section analysis is ongoing right now. Geochemical fingerprinting, digitize the graphic logs, and then, of course, characterize the Shunsby base metal prospect. So this was originally going to be the second publication was just on Shunsby alone, but having to incorporate all of Jefferson and Bencan, which was going to be its own standalone publication with Blake's Masters, has really pushed things later. And then there's a couple other spots, which I mentioned in the past, but also within the Women River information. It's not a deposit per se, but this is what we call the Jasper Mountain or Mortimer Magnan Jasper Prospect, where we have oxide facies iron formation. We have sulfide facies iron formation down here, and then a breccia with sulfide replacement in the matrix underneath. So just a small example, we have the samples and thin sections for this. So largely just going to have that as an addendum to the two main deposits. So just showing some pictures. That's the oxide zone. That's the sulfide zone. And then the replaced matrix stratigraphically underneath. And then the only place that we've seen thus far in Swayze that has massive sulfide mineralization that's not at an episode or assemblage boundary is this one over here, which is, there's no really name for it, but the best reference I can find is the Crichton showing. So we'll call that going forward. And this is an area where I had a BSc student with Jake Hanley working on what's going on in that area. And so that's going to be included in that second paper as well, just largely what the character of the different minerals within that massive sulfide and what it's doing, because it's the only area in the entire Swayze that actually has stereotypical massive sulfide mineralization within an assemblage. So basically just some concluding statements and or characterizations. So all significant base metal mineralization, excluding at Cote in the Swayze, is within the Women River Iron Formation, which represents the break between Deloro and Blake River and or something other in certain areas. And the hydrothermal mineralization and or alteration occurs stratigraphically below and within the Women River Iron Formation and sediments above, which we've now seen at Jefferson. But basically fine-tuning that right now. We talked about this, the only occurrence of massive sulfide mineralization recognized that doesn't occur within the iron formation is within the Blake River. And then basically next steps are just to put all this together this year and merge everything with the second manuscript. Blake did quite a bit of work writing already. So just to incorporate all of his observations with Shunsby and put that into the second manuscript, basically describing the character of these base metal prospects in the Swayze area. So, and for the larger scale for Abitibi implications, so this is all within that first manuscript that's been submitted now, but basically the Western Abitibi, so the Swayze area represents an area that's underlain by thicker, less juvenile crust, less volcanism, extension, and plume activity. We have abundant inherited zircons within volcanic rocks. The only synvolcanic intrusion known to date is the Chester Intrusive Complex, volcanic complex, sorry, that holds the Cote Gold deposit, which is Picard in age. There are long intervolcanic periods of sedimentation, and it's the only host to actual VMS-like deposits. The Blake River is extensive but relatively thin. We have no known central volcanic complex developed with it. There are komatiites indicating late rifting, and it has the only massive sulfide lens within an assemblage that we've seen in the Swayze area to date. So basically, what the Swayze area represents, it's an area that lacked thermally mature crusts required to form and sustain felsic volcanic centers, like over in the Norand area. They're associated high temperature magmatic hydrothermal systems and VMS deposits. So time, as we've seen, all three of those most important assemblages are within the Swayze area, but time as represented by these episodes assemblages is not necessarily indicative of VMS prospectivity. And then just showing again why we're doing this. So the VMS deposits in the Women River Formation and Swayze versus within assemblages in the rest of the Abitibi. So, and that's all I have.